For decades, our story of the early universe was remarkably straightforward. We pictured a dark, chaotic soup of raw hydrogen and helium gas. In those first few 100 million years, the cosmos was entirely featureless. Nothing complex or structured had yet formed. That was exactly the era the James Webb Space Telescope was built to investigate. By capturing infrared light stretched over billions of light years, its massive mirrors allow astronomers to peer into that primordial dark age, hoping to catch a glimpse of the universe's very first primitive stars igniting. But when James Webb actually looked, it didn't find a few sparse primitive stars. It found this. That tiny red smudge is Jade's GSZ 14.0. It is a massive, fully formed galaxy, sitting completely assembled just 290 million years after the Big Bang. Under the standard cosmological model, often called lambda CDM, this structure is a mathematical impossibility. Galaxies are supposed to grow slowly and hierarchically, as small clumps of gas merge into larger ones over billions of years. At 290 million years, a galaxy simply hasn't had the time to gather this much mass and settle into a mature shape. Finding a fully evolved galaxy in a cosmos that has barely begun forces an uncomfortable realization. The timeline of cosmic evolution we've relied on to explain the birth of our universe is breaking under the weight of new evidence. To confirm they weren't just looking at an instrument error or a trick of the light, independent teams turned to the ALMA radio telescope array in the Chilean desert. They needed to analyze the specific chemical signature of the light coming from this ancient galaxy. The radio data revealed a chemically mature environment, identifying concentrations of heavy oxygen that belong in a much older galaxy. In a young cosmos, we expected nearly pure hydrogen, but ALMA confirmed that Jade's GSZ 14-0 is already saturated with heavy elements. Oxygen does not spontaneously appear in empty space. It is a heavy element, forged exclusively deep inside the crushing high-pressure cores of massive stars, and it only disperses into a galaxy when those stars run out of fuel, collapse, and violently expel their contents in a supernova explosion. Generating this volume of oxygen requires multiple successive generations of stars to live, burn out, and explode. That cycle takes immense amounts of time, a process that vastly overshoots the tiny 290 million-year window available since the supposed Big Bang. The standard model of the early universe has no mechanism to produce this result. We are forced to choose between two difficult options. Either our dating of the universe is completely off, or the cosmos had a massive, unaccounted-for head start. Right now, cosmology is navigating a crisis. The equations and simulations that successfully predicted the large-scale structure of the cosmos for 30 years are suddenly failing to match reality at the most crucial boundary of space and time. And JD's GSCZ 14.0 is not an outlier. Astronomers are documenting an entire class of objects they're calling red monsters, galaxies packed with ancient, cool, red glowing stars that systematically violate every accepted rule for how quickly stellar mass can accumulate. You cannot fix this discrepancy by tweaking a variable or updating a sensor calibration. When the objects inside the universe appear older than the universe itself, astrophysics requires a completely new framework. That framework might come from Sir Roger Penrose, a Nobel-winning mathematical physicist. Penrose has spent years investigating a question that most cosmologists thought was impossible to answer. What exactly was happening before the Big Bang? His proposed solution is called Conformal Cyclic Cosmology, or CCC. Instead of treating the Big Bang as the absolute beginning of everything, CCC models a cosmos without a true start or an ultimate end. This diagram outlines his concept. The top section represents the far, infinite future of a universe. After trillions of years, black holes evaporate, all matter decays, and the universe is left as a boundless, cold expanse of pure, massless light. Without mass, the concepts of time and physical distance lose their mathematical meaning. This creates a counterintuitive mathematical reality. In conformal geometry, an infinitely expanded, cold, featureless void of light is perfectly identical to the infinitely small, dense, and hot singularity that triggered our Big Bang. Penrose calls these successive phases aeons. As shown by the vertical stack here, the cosmos operates in an infinite chain. The absolute decaying end of one universe creates the exact geometric and physical conditions to ignite the Big Bang of the next. If Penrose's math holds up, it elegantly resolves the James Webb anomaly. If our Big Bang was simply a continuation of a previous massive cosmic cycle, it completely explains how ancient heavy elements like oxygen could already exist and populate a galaxy so early in our own timeline. As cutting-edge as this quantum math is, the concept of an eternal, recycling cosmos is incredibly old. We have seen this specific architecture of death and rebirth before. Over 5 millennia ago, Vedic philosophy detailed a system of cosmic cycles, specifically the Mahakalpa and Mahapralaya. These cycles describe the day and night of Brahma, an endless, rhythmic process detailing the expansion and complete dissolution of the cosmos. This Vedic day of Brahma spans 8.64 billion years. To put that in perspective, it is nearly double the age of the Earth and the Sun, matching the multi-billion-year windows required for the generations of stars to produce the heavy elements we're now finding in the infant universe. The astronomer Carl Sagan famously pointed this out decades ago. He observed that Hindu cosmology is the only ancient faith dedicated to an infinite number of universe deaths and rebirths, and the only one whose timescales correspond directly to modern astrophysics. The fact that these 5,000-year-old texts mapped such precise durations provides an incredible historical precedent. Millennia before we had the math for conformal geometry, ancient thinkers had already deduced the eternal pulse of the cosmos. It leaves us with a lingering question. How did ancient sages map the precise cyclical mathematics of our universe thousands of years before the invention of optical telescopes or supercomputers? Whether we are pulling down infrared data from a $10 billion space observatory or deciphering the verses of an ancient manuscript, the cosmos appears to be telling us the exact same story, a story of endless, unyielding rebirth. The universe keeps recycling, and so do the mysteries. If you want to stay in the loop for the next cosmic breakdown, make sure to hit that subscribe button. See you in the next one.